What is going on? Question 2. What is this question is based on? This question is based on, just let me check. Okay, this question is based on intermolecular interaction. So we need to discuss boiling point of these molecules. So what are these molecules? This is a carboxylic acid. You know, when you look at carboxylic acid, make what? Carboxylic acid can make dimers. So it can make hydrogen bonds, two hydrogen bonds, and due to the formation of two hydrogen bonds, it can exist as dimers. We talked about that. This is alkane, branch alkane. When alkanes are branched, those molecules cannot be packed because the branch is going to hit each other. So branch alkanes will have what? Weaker intermolecular forces. This is alkane. Straight chain alkane will have stronger intermolecular forces, stronger dispersion forces because molecules are packed closely. Then the alcohol definitely it can make hydrogen bonds, but it cannot make dimers. Okay, when it comes to dimers, always remember it's all about the carboxylic acid. Don't worry about too much when it comes to other molecules, right? Okay. So the lowest boiling point should be this one. What is that? Because it's a branch alkane. So firstly, we have to say what are the reasons. Non-polar, only intermolecular forces are dispersion forces. So dispersions only, IMF, always remember to make sure, no, sorry, always remember to mention the intermolecular forces. So dispersion, because it's non-polar. But this is due to branching, higher branching. Higher branching, molecules are less packed. Higher branching, due to the higher branching, molecules are less packed. So weaker dispersion forces, weaker dispersion forces, weaker dispersion forces. All right, then the what is that? It comes here. It is 1, 2, 3, 4. Pentane. Pentane again non-polar. Then you have write non-polar dispersion forces. But more dispersion, yeah, dispersion forces. Since it is straight chain, molecules are tightly packed. Tightly packed, well packed. So stronger intermolecular forces compared to branch alkane. Therefore, stronger intermolecular forces compared to branch alkane, the previous one. The next one should be the alcohol. So just write those here. What is that? 1, 2, 3, 4 butane 1O. Polar. Hydrogen bonds, intermolecular IMF, hydrogen bonds, stronger compared to dispersion forces, right? Okay. Then the highest boiling point is the butanoic acid. Butanoic acid. Here. Butanoic acid. Why is that? Why is that butanoic acid? They can you could say each molecule can make two hydrogen bonds, two H bonds. Each molecule can make two hydrogen bonds. Therefore, they exist as dimers, form dimers. Form dimers. Make sure you mention the fact that they can each molecule can make two hydrogen bonds, right? So they can exist as dimers. All right, that's a simple question. Let's look at the higher solubility. Explain your response. Higher solubility, only what is the least solubility? This is non-polar. Only what? Dispersion forces. So that will have a dispersion forces. That will have a the lowest solubility. Lowest solubility. It should be this one, I guess. Yeah. Is it this one? Yeah, okay. Lower solubility because it cannot make any dipole or water is polar, so this is non-polar. Then the next one is a ether. You don't have to name ethers. That's interesting that they want us to compare the solubility of ethers. Yeah, it's interesting. Man, what to do? They have to compare the ethers. Okay, just give me a sec. Then the ether, yes. I mean, that is polar, but this is polar. Polar. So they can make dipole-dipole interaction. Dipole-dipole. Yeah, with the water. So there is a it is soluble compared to alkane. All right. Then what comes next? Then the next one is, this is also a polar molecule. Aldehyde are polar. Why? Look at this. Why? This is a polar molecule, but it hasn't got a hydrogen bonding hydrogen. So polar, dipole, 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 dipole. Now you might be asking, you might be thinking, how do you compare, how do you know the difference between, when it comes to solubilities, differences between ether and aldehyde? It can be a little bit tricky though, yeah. But I think aldehyde is more polar than this molecule here, because it has got a it has got an oxygen attached to carbon, one of the carbon. So that's one trick, I understand. But this one is pretty straightforward. It's polar, presence of hydrogen bonding hydrogen, hydrogen present. Therefore, hydrogen bonds, hydrogen bonding. Yeah, I mean, that question can be a little bit tricky with the ether and the aldehyde. Yeah. So the answer is polar molecules forms hydrogen bonds with water. Well, not the best question, but I hope that you got something out of that, because these are not, sometimes when it comes to these questions, not the perfect, but let's do our best. Okay. Now, viscosity, again, when it comes to viscosity, stronger the intermolecular forces they can make, higher the viscosity is. Remember, when there are stronger intermolecular forces, molecules can move slowly on top of each other. Yes, slowly. When there are less intermolecular interaction, weaker they can move past top of each other easily. Less viscous. Moving past means less viscous. Moving slow means more viscous. All right? Is that clear to you? All right. So in this case, they are all alcohol. So more the number of hydroxyl group you have, stronger more the hydrogen bonds you can make. Yeah, more the hydrogen bonds you can make. So this one, they are all straight chain, because branching increases the viscosity. No, decreases the viscosity. Branching. Yeah, decreases the viscosity, but they are all unbranched molecule. They are straight chain molecule. So this one has to have the highest viscosity. Number one. Why? It can make more hydrogen bonds due to the presence of 3 hydroxyl group. Next one is this one is because they got two hydroxyl group. The least viscous is the third one. So the viscosity. When it comes to viscosity, 1 is greater than 3 is greater than 2. That's the viscosity. Okay, you want some additional notes? Viscosity increases with what? Number 1, strength of the IMF. Strength of the IMF, okay, intermolecular forces, okay. 2, number of carbons, because more the carbons, more the dispersion forces. Oh, what happened, man? More the carbons, more the dispersion forces, right? Dispersion forces. More the carbon, more the dispersion forces. Is that clear? All right. So the third one is less branching. Let's say the branching, stronger the viscosity or stronger the intermolecular forces. All right. Then the answer is, what do you need to say? All three molecules are linear, and have the same number of carbon. So we are trying to say that they have the same, there are no branching and same amount of dispersion forces and same amount of carbon. Amount of carbon atoms, right? So you can pretty much say amount of dispersion forces, therefore amount of dispersion force, or the strength of the dispersion forces the same. Strength of the dispersion force is the same. When it comes to all those molecules, the strength of the dispersion force is the same. Strength of the dispersion forces are the same. Strength of the dispersion is same among the molecules. Among the molecules, right? However, greater the number of OH group, greater the hydrogen bonding they can make. However, greater the number of OH groups, greater the number of OH groups, greater the intermolecular hydrogen bonding. Intermolecular hydrogen bonding. All right, hydrogen bonding. All right, man. Okay. Did you do this? How did we go? Not bad, not bad, not bad. Oh, I'm excited to do the next question, which is, I'm excited to do the next question. Reaction pathways. I'll see you soon with another question. Question 3 later. Let me get something to eat. Bye-bye.